all about statistics. So we're going to start off by talking about the mean. Hopefully, some of these words are review for you. So the mean is when you find the total sum and you divide it by how many terms there are. So if you're looking at a set of data, your list of numbers, you are going to add them all up and then divide by how many numbers there were. For the median, you need to order your numbers from least to greatest, and then you're going to find the exact middle. The mode is the number that occurs the most. So you could have two numbers that occur 5 times in your data set, so they would both be the mode, or you can have all your numbers occur the same number of times, so in that case there would be no or none. The range is when you take the maximum and subtract the minimum. So you take the highest number and you minus the smallest number. Today we are going to be focusing on that mean formula. Another name for mean is average. So the average is when you take the sum, you divide it by how many numbers you have, and that gives you your mean. Let's practice. We want to find the mean of 7, 4, 9, and 12. So the first thing we have to do is add those numbers up, which will give us 42. Well, 42 is our sum divided by how many numbers we have. We have 5 numbers in this list. 42 divided by 5 is about 8.3. So 8.3 is our mean. For our median, we need to put our numbers in order from smallest to largest. So 4, 7, 9, 10, 12. I like to cross them off to keep track. 12 and 4, 7 and 10. We have 9 directly in the middle. So our median is 9. All of these numbers occur the same amount of time. So for mode, there is none. And then our range, we're going to take that maximum of 12, subtract that minimum of 4, and that gives us a range of 8. Another vocab word is an outlier. So an outlier is a piece of data that doesn't fit. It's either a lot higher than the rest of your numbers or a lot lower than the rest of your numbers. So looking at situation A, all of our numbers are fairly close together, and the mean, 83.5, is a good representation of these 4 test scores in situation A. In situation B, we have this outlier 45. And look at what that does to the mean. Our mean becomes 75. Well, 75 isn't really close to 84, 82, 89, or 45. So it's not a good representation of our data. And that's because of that outlier. The outlier causes it not to be an accurate representation of data. That 45 is pulling it down. Okay, so again, an outlier, it's a number that doesn't quite fit in. So it's either pulling your data up if it's really high, or pulling your data down if it's really low. We're going to focus on using our definition of our mean today. So basically, we're going to read a problem and use the given information to figure out what we don't know. So on the last 4 tests, you scored a 90%, 88%, 82%, and 96%. Your parents said you can't go on the trip unless you have an average of 90%. What do you need to get on your next test to get that average of 90%? All right. Well, in order to figure out what we need on that 5th test, right, we need to use our given information to find the sum. Okay, what should our sum of data be? So we're going to plug in what we know right now. Right now, we know that the mean we are looking for is 90%. Okay, we know that we want that mean of 90% after 5 tests, right? The 4 we've already taken and that 5th one that we are trying to figure out the score. We don't know the sum, right? The problem does not tell us the sum. But look at the equation we have set up. We have the sum divided by 5 equals 90. So we can use our skills from Unit 1 to solve for the sum. Well, the opposite of dividing by 5 is multiplying by 5. Our 5's cancel each other out, so our sum is equal to 450. So that tells us that our 5 tests should add up to be 450. Well, if our 5 tests should add up to be 450. That means if we take away the scores from our first four, so we subtract 90, we subtract 88, we subtract 82 and 96, what's left over will be what we need on that fifth test. When we subtract this, we're going to end up with 94. So we need an average of 94% on the fifth test in order, we need a score of 94% on the fifth test in order to get the mean of 90%. So this is our answer. So all we did, we took the given information, right, our how many and our mean to figure out what we didn't know, which was the sum. And we used that to answer our question. Let's take a look at another one. So to win the golf tournament, your team of 4 needs to have scored an average of 80 or lower. First 3 players scored 83, 78, and 82. What does the fourth score need to be to reach that desired average? Okay, well, what do we know? What's given? We know we need a mean of 80. We know that there are 4 people on our team. However, we don't know what the sum of their scores is. Right? We don't know that, but we need to. So we're going to solve this equation. The opposite of dividing by 4 is multiplying by 4. So we have our sum equals 320. Well, if all 4 scores add up to be 320, that means if we take 320 minus 83, 78, and 82, so subtract our first 3 scores, we are going to end up with what the fourth score needs to be. So when we subtract this, we will get 77. So the fourth player needs to get 77 or lower in order to get that desired average of 80 or lower. Needs to score 77. All right, so again, we use the information that was given to figure out what we didn't know. So all of this is just manipulating that equation. The sum divided by how many equals the mean. Let's switch gears just a little bit, still focusing on that equation, but doing something slightly different. So there are 20 students were asked how many text messages they send in a day. The mean number of text messages was 140. However, one of these 20 students said they sent 400 text messages a day. So what do we call this? The student data of 400, right? Because that's a lot higher than 140. So that is an outlier. Remember, that's our word for a piece of data that just doesn't fit. 400 just doesn't fit. Letter B, if you remove the student, so if we take out the student with 400 texts from the data, do we think the mean's going to get higher or lower? Well, they sent 400 text messages, which was really, really high. So when we take that out, our mean is going to drop. So our mean is going to be lower because the outlier, 400, is bringing the mean up. Right? That's causing it to go up. So without it, the mean will go down. It'll get lower. Letter C, what is the new mean without the student who sent 400 text messages? So we want to figure out the mean without that outlier student. So we're using that equation. Our mean equals the sum divided by how many. So we know that our mean is 140. We know that we are talking about 20 students, and that's going to allow us to find that original sum. Okay, the original sum for those original 20 students. So we're going to multiply both sides of this equation by 20 in order to figure out that original sum. Well, 140 times 20 is 2,800. So So the sum of all 20 students was 2,800. But we want to figure out the mean without that outlier. Okay, so without them, we want to take them out of our data. To take out that 400, we're going to subtract. So our original sum of 2,800 minus 400 leaves us with the sum of 2,400. Okay, remember 2,800, that was the sum of all 20 students. 400 was the data from one student. So that means 2,400 is the sum for the other 19 students. So 2,400 is the sum for how many? Well, 19 students. Look at what we have. We have a sum. We have how many. So we can figure out the mean. We can figure out the average of the other 19 students by taking 2,400 and dividing it by 19, which is about 126.32. So we can just round that to 126 text, not tests. Text is our average. So again, all we did here, that is our average without the outlier. All we did here was use this equation, the sum of data divided by how many equals the mean. We manipulated it a little bit to figure out the information we didn't have. Last thing we're going to look at is creating a list of 10 numbers that have a mean of 12, a median of 7, and no mode. So this list of numbers, all it really means or boils down to is understanding what it means to have these three things. Okay, this mean, this median, and no mode. Well, to have a mean of 12, okay, to have a mean of 12, let's look at what that tells us. We know we want our mean to be 12. We know we're talking about 10 numbers. However, we don't know what these 10 numbers should add up to be. But we can figure it out. So the sum of our 10 numbers needs to be 120. We're going to use that to create our list of 10 numbers. Okay, we know that 7 needs to be in the middle, but no mode tells us we can't repeat. So when we have 10 numbers, that means we are going to have our median. Okay, our median actually needs to be right here, right between our first 5 and our last 5 numbers. So since we can't repeat 7, we can't just put 7 and 7. So we need two numbers that 7 is directly in the middle of. Well, if we have 8 and 6, 7 is directly in the middle of 8 and 6, so 7 is our median. Okay, so no mode. From here on out, we just have to remember that we can't repeat any numbers. So our total is 120. Well, we've already used 6, we've already used 8, so that means the rest of our numbers have to add up to be 106. So from here on out, we can really just pick whatever we want. Okay, but we have to remember the data needs to be in order from least to greatest. So I'm just gonna pick, just randomly, whatever I want. Okay, well, I'm gonna start with 1, 2, I'm gonna skip 3, here's 4, 5. Notice how I didn't repeat any numbers. So I used 11 with my 1, 2, 4, 5. So I have 94 left. So my 12, 20, 30, 32, those all add up to 94. They're in order from least to greatest. So this is one example of numbers that fit the criteria of having a mean of 12, a median of 7, and no mode. There are multiple others. Just to review this definition, memorize it ASAP. The sum of data divided by how many tells us our mean.